Welcome to this month's VideoTec. In this release, we'll cover the functions, operation, and diagnosis of the factory-installed security alarm system on Jeep vehicles. The addition of the single-board engine controller, or SBEC2, to most of the Jeep model lineup for 1991 allows selected Cherokee models to offer a factory-installed alarm system for the first time. The Jeep security alarm system is currently standard equipment on all Cherokee Limited and Briarwood models. It is also available as an option on Cherokee Laredo. It is important to be aware of model availability, as there are many non-factory alarm systems available today, including Mopar systems like this one that you may have installed. This video and the accompanying materials are designed to cover only the factory-installed system on Jeep Cherokee. There are few visual clues to help determine whether a Cherokee is equipped with the factory system. In fact, the presence of a keypad or similar device will immediately signal that a system is not factory installed. But if you know where to look, identifying vehicles with the factory alarm system is simple. They all include the following visible components. The easiest to spot is the unique hood switch, located in the engine compartment near the battery. Less obvious is the Security Alarm Module, or SAM, which is located under the instrument panel. A flashing security lamp is included on the instrument panel, but it illuminates only after the illuminated entry system has timed out, and only if the security alarm system has been properly armed. And please note that while the Eagle Talon TSI does offer a factory-installed alarm system, it differs in both function and design from the Jeep system covered here. For information on servicing the Talon security alarm system, refer to the appropriate service manuals. A properly operating Jeep security alarm system provides several functions to help prevent theft. Once the system has been armed, improper opening of the doors, liftgate, or hood, or an attempt to start the vehicle will activate the audible and visible alarms. This will alert bystanders and can encourage a thief to move on to less conspicuous and unprotected vehicles. The horn pulses and the vehicle lamps flash in combination for approximately 3 minutes. If the monitored body part, in this case the door, is left open, the lights will continue to flash for an additional 15 minutes. If the door had been closed following the first break-in, the alarm would reset once the initial 3-minute stage had timed out. It would be triggered again should there be any further attempts to enter the vehicle. An engine kill feature provides additional protection from those not stopped by the audible and visible alarms. Attempts to start the vehicle will be prevented by the fuel injectors being disabled unless the security system has been properly disarmed. The vehicle may start, but it will not continue to run. A tamper alert function is included to indicate to the driver that the alarm had been activated and has since timed out. This alert consists of 3 horn pulses when the vehicle's security system is disarmed with the key or the keyless entry system. In addition, the illuminated entry system allows the driver to scan the vehicle for possible intruders hiding inside. There are many components which combine to create the Jeep security alarm system. In this segment, we'll examine their function and location on the vehicle. The heart of the system is the Security Alarm Module, or SAM. It is mounted in the passenger compartment on a bracket located on the driver's side of the heater air conditioner housing. The SAM monitors information provided by a number of input switches located throughout the vehicle. When the inputs do not match the pre-programmed set of conditions the SAM recognizes as normal operation, the SAM responds to those conditions with the appropriate output. For example, if the SAM receives the input message that allows the system to be armed, the output consists of the SAM causing the security lamp to flash. Now, if a door is opened, the SAM provides the output required for the alarm and engine kill functions. Let's take a closer look at the components which provide the SAM's inputs. The vehicle's door jamb switches not only operate the courtesy lights, they provide an input to the SAM. The switch remains open until the doors are opened. When the switch is closed, the SAM senses the voltage drop that develops when the path to ground is provided. The liftgate lamp switch and the hood switch, located in the engine compartment near the battery, work in the same way. A switch like this one is mounted to the back of each of the door and liftgate key cylinders to monitor key position. The switches normally remain in the open position. When the key is inserted and cycled to the unlock position, the switch provides a path to ground. The resulting voltage drop provides the SAM with another input to use in its decision-making process. The power door lock switches are also monitored by the SAM, but they provide their inputs in a different manner. The door lock switches remain in an open state until physically closed. The SAM receives an input of battery voltage when the switch is activated. The ignition switch works in much the same way, providing voltage inputs to the SAM when cycled to the accessory, run, or start positions. The keyless entry system is operated by a handheld transmitter that sends coded pulses of infrared light to a receiver mounted on the overhead console. The keyless entry module functions within the power door lock circuit, bypassing the power lock switches and providing battery power directly to the power lock and unlock relays when activated. As you can see, the SAM receives its input no matter how the power door locks are activated. Now that we've covered all of the SAM's inputs, let's look at the output side of the picture. The park and tail lamps are operated directly by the SAM, which provides them with battery voltage and a current of up to 5 amps through a circuit that bypasses their normal switches. The SAM operates the headlamps in the alarm mode through a security alarm module relay located underneath the instrument panel. When the SAM activates the alarm, it provides voltage to the relay. This causes the switch to close and the headlamps to be activated. The horns are operated through their existing relay, which is also located underneath the instrument panel. The SAM provides a path to ground other than through the horn switch. This triggers the horn relay and causes the horns to sound. One of the most important SAM outputs involves communication with the engine controller through a component which is common to both of them. A pair of twisted wires and microchips in each module form a communication link known as the Chrysler Collision Detection, or C²D bus. Its function is to prevent collisions of data, allowing an orderly flow of information to the engine controller. When the ignition is in the run position, the engine controller uses the C²D bus to continually monitor the SAM. The last message that the engine controller should have received from the SAM before the ignition was turned off was that the security system is disarmed. The engine controller must receive this same message the next time the vehicle is started, or it will cut the power to the fuel injectors and the engine will stall. The same thing will happen should the engine controller find no message at all because the SAM has been disconnected or the communication link has been lost. It takes 20 starts for an engine controller to become accustomed to the presence of a SAM. The engine kill feature of the system will not function at this time. This is by design to prevent disruptions during the in-plant assembly process. Following this 20-start learning period, the engine kill feature becomes functional, and an engine controller that has operated with a SAM will not allow an engine to run without one. Keep this in mind when performing other service on these vehicles. The final output function of the SAM concerns the operation of the security lamp located on the instrument cluster of the vehicle. The SAM provides the lamp circuit with a path to ground. This allows the bulb to illuminate when the system is being armed. One of the features of the Jeep security alarm system is that many of its functions are controlled by existing vehicle components. Of the components just covered, the hood switch, the key cylinder disarm switches, the security lamp, security alarm module relay, and of course the SAM itself are unique to the system. The Jeep security alarm system may be armed in two ways. To use the first method, it takes a combination of the ignition being off and a door or the liftgate being open. The power door lock switch must be used to lock the vehicle, and the door or liftgate must be closed. The second method of arming is by locking the doors and liftgate with the keyless entry system after leaving the vehicle. When either of these procedures is completed, the illuminated entry system will time out after about 30 seconds, and the security lamp on the instrument panel will then flash for approximately 15 seconds. Only when the security lamp is finished flashing is the Jeep security alarm system armed. Should a monitored system other than the hood be operated while the arming process is underway, the security alarm system will not be armed. It will have to be set once again. The methods just shown are the only two ways to arm the system: engaging the power door locks with the doors closed while remaining inside of the vehicle, or manually cycling the key in the door lock will not arm the system. Remember, new vehicles must be started 20 times before the engine disabling function will activate. Vehicles that have had their engine controllers replaced will also need to be started 20 times before the engine kill feature will function. This should be done prior to customer delivery as part of your road-ready prep. Once the system is armed, an alarm is activated by opening the doors or liftgate without using the key. Opening the hood or operating the ignition switch, even with the key, will cause the alarm to activate. You may hear customer complaints about the alarm activating when they exit or attempt to start their vehicles. This is caused by occupants inadvertently arming the security system. Let's look at how this might happen. One method is by pressing the keyless entry transmitter while in the vehicle. If this is done prior to the vehicle being started, opening a door or operating the ignition will trigger the alarm and the engine kill feature. The SAM has no way of knowing that the system wasn't armed from outside of the vehicle. In this next method of owner activation, the SAM is also fooled. Suppose the driver parks the vehicle, turns off the ignition, lets a passenger out, and then operates the power door locks from either the master door lock control or the switch on the passenger's door. Perhaps the driver wants to feel secure while waiting for the passenger to return. If the door was open when the locks were activated, the SAM had no way of knowing that when the door was closed, the occupants didn't leave. The system is armed, and opening a door or operating the ignition will activate the alarm and engine kill feature. Once customers are aware of the logic the SAM uses during arming, they can avoid unintentionally activating the alarm. One method of activation that you are sure to encounter occurs when the vehicle's power supply is interrupted. This can happen when the battery or SAM is disconnected. Upon the restoration of power to the vehicle's electrical system, the vehicle lights will flash and the fuel injection system will be disabled. The horn will not sound in these instances. When performing electrical service on a vehicle with this security alarm system, anticipate the additional power draw caused by the headlight activation when reconnecting the battery. Take the necessary precautions to protect your sensitive test equipment from possible damage. Disarming the system is accomplished by either unlocking the vehicle with the keyless entry system or by manually cycling the door or liftgate locks to the unlock position with the key. In either case, the SAM receives inputs which allow it to turn off the security alarm system. When the vehicle is started, the engine controller will allow the fuel system to operate normally. Remember that the security alarm system cannot be disarmed by removing the battery or security alarm module. In fact, just the opposite occurs. When system power is restored, the lights will flash and the engine will have been disabled. DRB2 diagnostics are not offered on the Jeep security alarm system. However, the system has been designed to include a series of comprehensive self-diagnostic tests to assist you in making the proper diagnosis and repairs. The security lamp on the instrument panel can serve as a good indicator of system health. It should flash for 15 seconds immediately after the illuminated entry lights have timed out to signal that the system is being armed. A security lamp that is continuously lit during this time period indicates a problem with the operation of the hood switch circuit. Perhaps the hood is not fully closed, or the switch is defective or out of alignment. In this situation, the system will still arm, but the protection normally given the engine compartment will not be provided. Should the security lamp remain on while the vehicle is running, the security alarm's communication with the engine controller through the C²D bus has probably been lost. The engine kill feature will no longer function. Should the C²D bus fail while the vehicle is parked, the engine will not run. To test the C²D bus, cycle the ignition key to the run position. Measure at the engine controller the voltage between cavity 26 and ground and cavity 46 and ground. Readings of approximately 2.5 volts should be measured in each case. Should the security lamp fail to illuminate during the arming process, there are several possible problems. An improper connection at the SAM could be the problem. If not, the 10-amp dome fuse or the bulb for the security lamp itself are the likely cause. When a system malfunction is reported, carefully inspect the many fuses that play a role in proper system operation. These include the flash to pass, headlamp delay, dome lamp, and clock fuses. A diagnostics mode is included in the system to verify operation of all monitored switches or circuits. To enter diagnostics, cycle the ignition key to the accessory position 3 times and leave the key in the accessory position. The horn will sound twice and the security lamp will flash. Headlamps, tail, and parking lamps should also begin flashing. In this manner, we are quickly able to test almost all of the SAM's output functions. Returning the key to the off position will stop the lamps from flashing, but keep the system in the diagnostics mode. Turn the key to the lock position and remove the ignition key. Now we'll prepare to test the SAM's inputs. You'll want to remove the tan illuminated entry module. It's located on a bracket with 2 black relays under the instrument panel. This requires a bit of reaching, but will allow you to test door and liftgate switches without having to allow for a 30-second delay between each operation. Beginning with all doors closed, open, then close each door. The horn will sound when the door opens, and then again when it closes. Allow a 1-second delay between opening and closing each switch. Do the same for the liftgate. Then open and close the hood. The horn sounding during each of these operations indicates that the circuit and switch at that location are functioning properly. Failure of the horn to sound indicates a problem with the switch, wiring, or SAM output providing the path to ground. Operation of the power door and liftgate locks with the keyless entry system should also result in the horn sounding. Remember to allow a 1-second delay between locking and unlocking. Rotate the key in each of the vehicle's exterior lock cylinders to the unlock position. This will also test the lock cylinder disarm switch mounted to the back of each lock cylinder. Again, the horn should sound as the switch closes and also as it opens. Failure to do so indicates a failure of the lock cylinder disarm switch. Cycle the ignition key to the run position. A single horn pulse will indicate proper operation of the ignition input. This also takes the SAM out of the diagnostics mode. Finally, don't forget to reconnect the illuminated entry module that was removed at the beginning of this procedure. That completes the self-diagnostic capability of the Jeep security alarm system. As you can see, its coverage of almost every SAM input and output function goes a long way in helping to quickly track down any defects in the system. A customer has brought her 1991 Cherokee Laredo in for service with the complaint that the vehicle's headlamps are not flashing when the alarm is activated. The fact that the lamps function normally when the switch is used leads us to believe that the fault lies somewhere in the security alarm system. Let's use the information we've just covered and the reference guide included with this video to solve the problem. Enter the diagnostic mode to provide an overall test of the system's outputs. Start by cycling the key to the accessory position 3 times, leaving it in the accessory position the final time. The fact that all functions except the headlamps are operating properly indicates that the problem is most likely in the headlamp circuit. Measure the SAM's output to the headlamps by back probing at pin 7 of the SAM connector. This is served by a tan wire with a pink tracer. An intermittent supply of battery voltage should be present between this point and ground. A lack of voltage at this connector would indicate that the SAM has failed. In this case, the SAM is okay, so turn the ignition to run and then to off to take the system out of the diagnostic mode. Reach under the instrument panel and remove the security alarm module relay for testing. Use an ohm meter to check for continuity between the terminals labeled 85 and 86. If there is an open circuit between these leads, the relay is bad and it must be replaced. Install a new relay. Enter the diagnostic mode once again to test the system for proper operation. That does it for this month's VideoTec. Consult your 1991 Jeep service manual and the reference materials included with this tape for additional assistance with the Jeep security alarm system. We'll see you next time on VideoTec.
The safety recall detailed in this program involves 1988, 1989, and 1990 model year Eagle Premier and 1990 Dodge Monaco passenger cars built before May 1990. On all affected vehicles, the front wheel brake hose routing may cause excessive hose flexing at the end fittings, which could result in fatigue cracking of the hose cover and eventual hose failure. Also on 1989 and 1990 model year vehicles only, a fuel tank heat shield may contact and damage the left rear brake tube when the rear suspension is in a full jounce position. To eliminate these potential problem conditions, 2 service procedures must be performed. On all involved vehicles, both front brake hoses must be replaced with redesigned hoses that provide a modified routing configuration. And on 1989 and 1990 vehicles only, the fuel tank heat shield must be modified to prevent possible contact between the shield and the left rear brake tube. For repair of affected vehicles, a partial quantity of front brake hose parts packages, part number C3940401, will be shipped and billed to involved dealers in accordance with the newly announced recall parts pricing policy. To begin the service procedure, both front brake hoses must be replaced on all involved vehicles. To do this, first fill the master cylinder reservoir to the proper fill mark with new Mopar brake fluid or an equivalent, which meets SAE J1703 and DOT3 standards. Next, to prevent drainage of the master cylinder reservoir during hose removal, install a pedal prop rod from the brake pedal to the seat track. Only apply minimal pedal effort to avoid high pressure. Now, raise the vehicle on a hoist and disconnect the front brake tube nut from the hose, and allow the released brake fluid to drain into a suitable container. The drained brake fluid must not be reused. After disconnecting the tube nut, remove and discard the spring clip and lower the end of the hose, allowing any additional brake fluid to drain. Next, remove the banjo bolt from the caliper and remove and discard the 2 copper washers from the bolt. Next, install a new brake hose with the washer supplied in the package. Finger tighten the banjo bolt to the caliper with the banjo block sandwiched between the washers. Line up the anti-rotation ledge of the banjo block to the flat side of the caliper boss. The brake hose assembly should be positioned so that the white foam spacer just contacts the strut body as shown here. After properly positioning the brake hose, tighten the banjo bolt to 31 foot-pounds or 42 Newton-meters. Hold the hose in place while tightening so that the spacer remains in its proper position. Next, insert the hose elbow into the body bracket as shown here, and install the new spring clip from the parts package to secure the elbow to the body bracket. The flats on the elbow will properly position the hose so that the elbow is 30 degrees toward the rear of the vehicle. Next, tighten the brake tube nut to 14 foot-pounds or 19 Newton-meters. These same steps should be repeated exactly in this order to replace the front brake hose on the opposite side of the vehicle. After replacing both front brake hoses, remove the brake pedal prop rod and then follow the applicable 1990 Premier Monaco Service Manual procedure to thoroughly bleed both front brake calipers. While bleeding, be sure to check the brake fluid reservoir level and add fluid as necessary. Next, on 1989 and 1990 model year vehicles only, the fuel tank shield must be modified. To do this, first locate the fuel tank shield, which is mounted between the tank and the exhaust system tailpipe on the left rear side of the vehicle underbody. Measure 2 inches from the lower tip of the shield and mark a diagonal line as shown here. Now, bend the shield on the marked line away from the fuel tank. If the left rear brake tube is positioned away from the rear suspension crossmember as shown here, move the brake tube forward so that it is positioned against the crossmember. Finally, inspect the brake tube for any signs of fluid leakage due to damage from prior contact with the heat shield. If damage has caused fluid leakage, the tube must be replaced following normal brake tube servicing procedures outlined in the service manual. Dealers are urged to give their full support to this important program by serving all involved owners promptly and courteously. For further information regarding vehicle lists, service procedures, and claim reporting procedures, refer to the Dealer Safety Recall Notification Letter, number 486.